I am Titus Winters. For a number of years, I was the tech lead for Google's C++ library team. I'm one of Google's C++ style arbiters, so I'm partly to blame for hopefully the improvements in the style guide that you've seen over the years. I'm definitely to blame for that not getting republished regularly. Because I've had a role in trying to maintain a very large code base for a number of years. You can try. Testing has become increasingly important. And so I'm going to tell some sort of anecdotes. This is a talk in roughly 3 parts. Testing as a historical part of software engineering orthodoxy, best practice. How to conceptualize what you want a good test to do, which is sort of cribbed from a CPPCon talk I gave a couple years ago. I will kind of breeze through that part because you can see the full talk elsewhere. And how testing will affect the future of software engineering. Good? It's good enough for me.
Probably fine, yeah.
So history. One of the things about our discipline, I'm not really aware of there being any solid scholarship on software engineering norms over time, right? We really don't pay attention to the fact that our discipline changes over time for some reason, and there certainly aren't people studying that change. But I can give you some anecdotes. So I first started hearing people talking about testing in the early 2000s. In the mid-2000s, the companies I was working for didn't require it, and in fact, I had to ask special permission to take some time to go write unit tests for the libraries I was working on. Somewhere around 2006, Google engineering went through some internal upheavals to bring people around to, yes, we require testing, period, full stop. And I suspect that the leading edge of groups that buy into testing, the timeframes are about like that. It's somewhere in the 2000s to early 2010s when you fully committed, right? And interestingly, this seems to be supported by Google Ngrams. This is hardly unimpeachable evidence, but it's anecdote at least. I'll have to go harass someone to get data past 2008. But largely the graph shows this basic idea, right? Testing started to be a thing in the late 90s, and we've certainly not seen full saturation yet. For comparison on this notion, we can look at other topics in software engineering orthodoxy. Take version control. Anecdotally, when version control was first introduced to me in the late 90s, it was not universally accepted as a best practice. And over the next 10 years, it encountered quite a few professional groups that didn't use it. But the graph basically shows that version control started to be a thing in the late 70s and early 80s and is continuing to rise. But it has evolved over time. It's clearly taught in schools now all the time. It's no longer odd to encounter students who are using it for term projects or even just like a week-long project. And today, very different from how it was 15 or 20 years ago, you can occasionally find professional groups that aren't using version control, but they are clearly weird, right? They are the amateurs, right? This has become totally normal best practice, right? And so put another way, even though it's been around for a good long while, version control has gone from, you should do this, we know, trust us, to, of course, everyone does that. And depending on how you read the implicit comparisons in the graph here, testing is 20 years behind, okay? Personally, from what I've seen and heard in the last few years, I would maybe call it 10 or 15. I think the uptake is a little bit quicker, but the direction is clear. We've got a ways to go, but in general, it only takes a few people that have had good experience with testing to convert any group. So in the end, in a mimetic sense, testing will win, right? There's no way around this. That doesn't mean it's a clear path or that everyone is bought in. Do you have a question, Bryce?
Yeah, so as somebody who wasn't around prior to this testing era that you have here, how did software work?
As a matter of fact, in the early 90s, regression testing was well established, so probably you should have searched instead of unit test in one word.
I have tried this graph with regression testing as well. It does not significantly change, right? Like, it's around. People sort of know about it, but largely I think you get a lot more of regression testing for big systems and stuff. But conceptually, it is not orthodox in software engineering until fairly recently. Arthur?
As long as we're heckling, I just Googled, and the Unitest module showed up in Python 2.1 in 2001. So I suspect that one word spelling of Unitest.
And there is a different historical perspective in that Unitest started from the Smalltalk people, and then they moved on to Java because Smalltalk became, Java became market dominant, and they brought the whole Smalltalk mentality of doing the unit test because, all the interactiveness and all that built into the Java and JUnit and everything else. And then following that, C++ people decided, Java sucks, but unit test maybe okay.
Right. I mean, there's lots of reasons why this is happening, but my point is, we're getting there.
Yeah.
Regardless of language. And not everyone is bought in, okay? And I think that a lot of people still have some resistance to this, and they view tests in one of two incorrect ways. The first, tests are for people that aren't sure that their change was right, but I am a good programmer, so I don't need it. And that is, I can develop code that is valued continuously going forward, my new feature, or code that is only valuable right now when I'm developing it, the test, right? So clearly, it is logical to focus on the thing that gives you ON value instead of O1 value. And this is a very common way that people misinterpret testing. This is fundamentally misleading and conflates development of the current feature with development and maintenance of the system as a whole. Like many things, this depends on context. If you're writing up a quick utility that you're going to use once and discard, don't write tests, right? That's a waste of time, right? If you're writing a new feature in an existing complex system, Google search, it's important to have tests for the existing things in place to know that you haven't broken anything else, and that once your feature is done and committed, that the idiot down the hall trying to add their feature doesn't break yours, right? So it is, in fact, value over time, not just value at the instant that you're developing it. But of course, as I suggested, context matters. And I will say that louder. Context is key. It is a very, very different thing to write code that looks good on a slide when you're giving a keynote, or to just hack something together quickly, than to build code with an expected lifespan in years or decades. And I encourage everyone to really think, what is the expected lifespan of the code that you've been working on recently? And in my mind, there's a reasonable range of about 4 orders of magnitude in answers to that question, right? It is insanity to believe that best practices on one end of that range are the same as best practices on the other, right? Context is key. A friend of mine recently described testing by analogy to road construction and repair, right? It might be annoying at the moment and causes some traffic for a few weeks, but over a few years it pays off. Implicit in that assumption is that there will be years for it to pay off, right? If we're told that an asteroid is on collision course for Earth and going to kill us all next week, you should stop road construction. You should also probably stop writing tests, right? Context matters. And in there, if you are going to write code that needs to be maintained, you should write tests. If you're in a context where all of this makes sense, then let's talk a little bit about what good tests look like. Okay, so first thing that you're going to find, there's discussions of unit tests versus integration tests. And when we start with unit tests, this is, you're trying to build tests for just the thing that you're working on, right? And my guidance is build unit tests just for you, not for the levels below you, right? Because there's no theoretically grounded way to stop, right? Where do you stop? Are you going to build unit tests to make sure that your instruction set also works as advertised? Where do you draw the line? And if you're building a whole code base, tests that you add on the functionality of other APIs are reducing the options. They're adding constraints on the maintainers of those other APIs, which as a maintainer with about 11,000 users, this will make you cry, right? It's no fun at all when people are like incorrectly adding constraints to your library. So keep your unit tests near what they are testing, same directory, related directory, right? Something like that, and keep the tests well focused. And in theory, I will claim that if you have well-designed unit tests, you should be done. You might need fakes or stubs to abstract away the interfaces of production systems, or mocks to test your error handling behavior. But if your tests are well-designed and your mocks and stubs and fakes are robust, that should suffice. But of course, tests are code and code has bugs, and most tests themselves are untested, and few engineers are yet equipped to identify the difference between a good, concise, robust, resilient test or a flaky, brittle, poorly designed one. And so as the number of interactions goes up and your number of subsystems goes up in your binary, the odds go up that your unit tests stop providing the intended benefit and you start looking into something higher level. These are integration tests. Congratulations, you've now justified investment in integration testing. In a nutshell, integration testing is attempts to spin up increasingly real versions of your various subsystems disjoint from the real production environment in an attempt to bypass the bugs from your iffy mocks and incomplete unit tests. My very speculative guess is that in a magical future where testing is accepted and engineers can tell the difference between good tests and bad, and that we've got better hygiene around mocks and stubs and fakes, that integration testing should fall away. In the interim, in practical terms, after a few production bugs and release delays, most sufficiently large groups are going to eventually invest in integration tests. I have personally been sufficiently removed from big production issues that I don't have a good grounded theory on integration tests, and I'd love someone to convince me that they are theoretically important in addition to just practically important. Room for discussion at the bar. There are properties of good tests. This is sort of stuff that you can catch in other talks that I've given. Broadly, they should be correct, they should be clear, readable, they should be complete, they need to test everything. They should have good explanatory power. A test is a lovely form of documentation on how your system, how your API should actually work, and they should be resilient. Things around them will change over time. Your test should only fail if the invariant that you actually care about is no longer holding, not the supplementals. And I will quickly go through a couple examples along these lines. Please don't write tests that depend on known bugs. This sounds obvious, you'd be surprised. Consider the case of, I haven't implemented this yet. Clearly, this is a bug. We have encountered this test, right? You do have to think about these things. The fact that it is a test does not make it intrinsically correct or giving good value. In the simplest forms, this is pretty obvious, but you can certainly imagine it being more complex. This is even worse when the tests appear far away from the implementation API and you don't see this note. Tests must actually execute real scenarios. If you have nice systems, mocks and fakes and stubs, we can fake things out for simplicity. The fake world is like the real world, except it's flat. Right? The further you get from reality, the less value your test really has. We can also stub out our behavior. We say, if you see a call to is flat, then we're just going to say that it's true. These tests start being very complicated and looking really good on screen, and increasingly just don't test anything. We encounter this a lot. And it gets even worse when you start having mocks. These are the types of tests where the test will only pass if this call is actually executed, perhaps exactly that number of times. When you start adding mocks, like things that enforce a certain call sequence, especially if you're adding mocks from far away, right? Not in your library itself, but from some other user has added mock tests to your code.
You can add conditionals there.
Was that?
You can add conditional people using conditionals depending on whatever flags it has in to set the bar to this value or that value
Yeah.
to run the test. And then
They can wind up completely preventing you from making any change to the implementation of your code.
Right.
They are enforcing, they're brittly enforcing invariants that you did not promise. Yeah. Tests should be readable, right? Don't write tests that have too much boilerplate and other distraction. Same true for most code, but it's very easy to find tests that look more or less like this. You have all of this complicated stuff. This is actually the only part that we are testing, but there's no visual indication of like what part are we testing here. You can take this too far. Don't write tests that have not enough context. Yes.
Oh, in the previous slide, I just recognized that like thread for 10. Yeah, actually, what if?
Right. And like, who cares? Yeah.
Yeah.
Like this is not. Yeah. Most of this is not relevant to what is actually the purpose of the test.
And, the magic number can make or break
Sometimes.
depending on the machine
Right.
run.
Yep.
So in scenarios like this where you need to have some sort of elaborate setup before you can actually do the test, do you have any suggestions on how we could kind of like hide some of this meaningless setup, maybe like stuff it into a fixture or something?
You can stuff it into a fixture so long as you very clearly describe, like, this is what is being done in the fixture, right? Like, the fixture is an API that you are designing in order to express clear, concise tests, right? But you have to approach it as an API design, like, right? Don't hide too much, don't hide too little, right? Try to keep the data flow clear so that someone reading the test has a chance to actually understand what's going on without just scrolling back and forth all the time. We'll see an example here. Similarly, don't go too far the other way. Keep enough context in the test. If you design your fixture so that it hides absolutely everything, I have no idea if this is correct, right? This test could pass. Doesn't mean it's correct. And I do have a tendency to recommend against advanced frameworks. I have pushed very hard against using fixtures in general. Sometimes they are very well justified, but not all the time. So for an example here, right? Here we have a fixture. I'm testing some sort of big system. And in the end, using this fixture, I expect that I can actually initialize the system. But if you look at this, these are all of the lines that actually mention file name. And these are all of the lines that mention system. And those are fairly disjoint. And so I'm pretty sure that that whole thing boils down to just this. And if it doesn't, then that means that there's some weird dependence between big system and a particular file path on disk, which is probably a terrible API to begin with, and you definitely have a documentation like task in front of you, right? Clarity in your testing goes a long way. A test should be like a novel. Setup, action, conclusion should all make sense. It should flow simply. Yes?
So, in your last example, you seem to be suggesting that if you have trouble writing a clear test, maybe you should reflect on the thing that you're testing, that it might not quite be right.
Right. I am a big fan of test first, like test-driven development, not specifically because of intrinsic good, but because it very much tends to produce APIs that are easier to use. So, don't test only the easy cases, because you can have an implementation that passes the easy cases and still isn't doing much good. My favorite way to drive this home, it's a great exercise. We occasionally run internal instances of Code Retreat, which I highly recommend. The idea in Code Retreat is to think about software engineering and practicing your skills and just doing some repetitive sorts of practice, generally in pairs. And one of the Code Retreat variants that I really like is to put one person in charge of writing tests and the other person in charge of getting them to pass without implementing the program. Right? And you can take this to amazing lengths, right? Especially in things like Python, where you can like introspect on the random number stream, and like it becomes a wonderful exercise in escalation. And it's not really a real like scenario, but it does drive home like you do have to go fairly far to have tests that are demonstrably complete. So write more extreme tests. Test the hard cases. Tests should be demonstrative. If you have friends and private methods for protected methods or private methods just for testing, you've probably designed the wrong API. And this should really just be call setup. Right? Use the public API. If that's not working, you designed the wrong thing. And tests should be resilient. These are the war story part. Avoid flaky tests. If you have sleep, you're probably doing it wrong. Avoid brittle tests. Oh my lord, this is the worst. Somewhere in here, I infer there's a hash table. Right? The reason that these elements are coming out in that order is because of just the order that we happen to traverse the hash. Right? Don't depend on hash traversal order unless you are using a hash container that specifically says, I guarantee to be using this hash, and this hash is stable. Right? If you change things very slightly, you can have clearer and more resilient code, and the people that maintain your containers can optimize things better, can change the hash traversal order, right, without breaking your test. Yes?
I guess the name of that unit test is probably also not very helpful. That contents are correct.
True. Yes. No, it's slide code.
Yeah.
Yes. No. I would not allow this through code review for certain. Avoid brittle tests. This is an example, sort of only mildly bogus, of a problem that I have actually encountered, which is this test will fail if you refactor file.cc by adding a line anywhere above line 421, right? So doing things like adding an include will cause a test, possibly in a faraway library, a faraway package to break. This is not okay, right? The invariant was not, they were not expressing the correct invariant, right? Also, this sort of thing will drive your library maintainers insane. I love image compression tests because this is 2 slides. Test that actually enforces the same binary output fails when you update the image compression libraries. They didn't actually care, but you've made the maintainer's job harder, right? And when your maintainer is trying to upgrade ImageMagick, which has been, described as a collection of security vulnerabilities that also happens to do image processing, you don't want to make this any harder. Oh, you okay? So, figure out what invariant you actually want. Don't write tests that fail if you don't run them in the right order. Don't write tests that actually talk to production servers, and you're the only person in your organization that can run this test at that time. Like, this is not a good plan. Don't do that. I'm not even going to get into that. I mentioned it. So,
I was interested in that.
this is basically the example of your mock adding explicit dependency on a particular call chain.
Oh, okay.
Right? And I would love to refactor this so that things are better, but because of your mock, I can't actually change that particular call chain. Right? Like, that's not the invariant you wanted. So, recap, First, yes, write tests, right? Everyone's going to do it in the next 10 years or so. Just get on board. Write tests that test what you wanted to test. Write readable tests. Those will be more correct by inspection. Tests are untested, so you really need to aim for correct by inspection. Write complete tests, test all the edge cases. Write demonstrative tests that show how to use the API. If your tests stop being readable, you probably built the wrong API. And write resilient tests that don't break when your maintainers do their job. Then, if you've done all that, then we can talk about what's next. So I was asked the other day, this is part 3, what do you think is the biggest upcoming sea change in software development? It clearly was scalability, right? We have these compute fleets now. It's amazing. What's coming next? And honestly, I don't have a single answer. I think there's a whole related spectrum of things that are coming, and part of it is predicated on testing. So 1, we're going to have better inter-repo, how do we fix this? Better inter-repo dependency. There seems to be momentum away from, hey, I downloaded a tarball, and towards, I will pull from head or the current stable tag in order to build my project. Right? And the more that you stay at head, the better that we avoid the dependency hell problems. We are also getting into talking about semantic indexing, knowing who is calling your code perfectly, and in some cases across repositories. There's a project company, SourceGraph, is doing very cool things here. Google is open sourcing Kithe. Indexing is transformative. The teams that I've worked on for the last 5 years, we just cannot do our job without the indexer at this point. One of the problems that my team currently is fighting is we're moving a lot of code around in the code base, and we want to remove unnecessary pound includes from headers in old files. Right? This is a terrible problem to have, right? Because someone is depending on that transitively. We have a great indexer, right? So we ask the indexer, tell me all of the symbols that are defined in that header that we're trying to remove, and then walk the include graph to find all of the places that they are referencing those symbols but haven't included something, and put in the minimum set of includes to fix the include dependency problem. And we've gotten that down to the point that for our 100 million line code base, we can run that task in a couple hours. Just done, right? Makes me very happy. Indexing is amazing. Yeah, I figured. Oh, and you get things like where's the variable referenced, what types are used when instantiating a template, like all sorts of information. And then tooling, right? Chandler has built me wonderful toys over the years. We get tool-assisted code transformation. This is coming. It's not just Google, it's all sorts of groups. If we have visibility into where our code is being called and tests to know when things are working, then we can finally solve one of the oldest issues in software engineering, fear of change, and the associated need to support ever-growing legacy, right? We've been giving talks, Google, on automated code transformation and the workflows that we use for that. We've repeatedly exercised changes that touch basically every file in the code base, and we've done it safely, and we've done it with increasing speed. We've almost never caused production problems, I think maybe twice, and even build system issues that require rollbacks are rare, like less than 1 in 100,000, something like that. In order to know that any such individual piece of change is safe, we simply have to rely on good unit tests. The single most common statement that I get after talking about code transformation and automatic refactoring is, oh, now I get why testing is important. Right? These all go together. And when we look at examples here, we can look at changing stuff like a string printf into a slightly better API. So one of the cleanups that I have going on, this is actually relevant, we have a cleanup going on to change our internal int64 type, which was defined 15 years ago before the standard had an int64. and we just type-defed it to be long. That is not actually guaranteed by the standard to be 64 bits. It is on all of the platforms that we care about, so that's nice. But we would like to move to the standard. Unfortunately, %LLD stands for long. It doesn't stand for something that happens to be 64 bits. Right? So if we fix that type-def, we will break the build everywhere. This is not a problem that is amenable to fixing by hand. There's about 50,000 calls to this function in our codebase. So we can just run a tool to go identify all of those calls, transform them into something equivalent. In this case, it's actually even more efficient, and it is completely safe. Even in the places where there's a tooling error, a bad merge conflict, things like that, we have unit tests. Things like you have defense in depth. Or you can even have your tooling be smart enough to realize, oh, this was a semantically equivalent change, string printf to string strcat, but in this context, we can simplify further. Right? And we're building up tools to increasingly just, oh, I touched a thing, now it simplifies different. Done. And so with the convergence of all of these things, unit tests, inter-repo dependencies, semantic indexing, code assistant transformation, we get a new life cycle for enterprise code. And that is what I think is upcoming. Code is not a stable, stagnant, thrown over the wall and done product. It is a living piece of engineering working in conjunction with everything around it, possibly across repositories, all throughout GitHub, all of that stuff. As things shift and update, as APIs change, the only way to know that we've done that change in the right way is to have a reliable set of unit tests. This, of course, has to be done with permission to change and assignment default going to lack of tests. One of the most important policies that Google engineering has is, we call it the Beyonce rule. If the janitors make a change and your code breaks, but you didn't have a test, not our fault. Right? If you liked it, you should have put a test on it. And when we get to this world, right, we finally have a path to sustainability. Right? And this touches on something that I think is really important and I've spoken about before. Over a long enough time frame, change is inevitable. Something you depend upon will be determined to be unsafe or buggy, and you will have to update. Right? Look ahead 10 or 20 or 50 years. If you are still trying to build for C++ 98, something is clearly and deeply wrong. Over the expected lifespan of your code base, of your project, you have to be able to react to change in your environment and your circumstance for anything that's going to come your way. You can choose not to. That would be technical debt. But if you're incapable of, then you're gambling like existentially on nothing bad is going to happen. And that is kind of a big gamble to take when the code base is probably the most important thing your organization has. That's my thought. Yes?
I have a few questions. Those are really good ideas about what are good tests, etc. Are there any such models for testing concurrent APIs? That's one question
I don't think that the goals of testing change because of concurrency. Like, you have to define the invariants of your type, like the type safety, things like that. You will have to test them in concurrent mechanisms. One of the things that I really like with Google sort of tools, Thread Sanitizer, makes concurrency testing very nice, so long as you have unit tests that actually test from different threads. So I will often just test all of the correctness stuff, test my normal invariants, then spin up a thread pool and just hammer all of the public APIs and run that under TSAN. And if I have screwed anything up, Kostya's work will find it for me. So.
I think that's that's just one way of looking at the concurrency.
Mm-hmm.
The other thing is say you're making a network call
Yes.
And you're going to like wait for a while, and then you'll check if the answer is right or not. And that delay could it could cause false negatives in the
Mhm.
in the testing server, and that's caused a lot of time people to go change things. Not that I do it, but I'm just like
Right. No. So this actually goes to unit tests versus integration tests, right? You should ideally be testing like the logic locally to the extent that you possibly can, right? And for a when you have things mock stubs and fakes, right? You can avoid actually making that network call for an increasing amount of validating that the logic of your thing is correct, right? At the point that you actually need to know that it works, that you're not just falsely depending on like an artificially constrained, overly simplified thing, then you start needing actually things like integration tests, and you probably need the ability to spin up something like a reduced capacity version of that server and test that like end to end it actually all works. But yeah, you do have to have mechanisms for that. Those just get more expensive and flakier and harder to run the bigger and bigger those systems get. Mm-hmm.
so. Are there like is there a mechanism available right now or in the future where some of the data could automatically be generated? Like say for example you're doing sum, or you're doing say for
You really want to come to Kostya's talk in a couple weeks. Kostya's talk on fuzz testing. Like he's done beautiful work on basically that sort of thing, right? And the results are astonishing. So yeah. I think I saw you first.
I have a response to the testing thing and then a question. So I work on a large parallel programming framework, and but we sort of have two classes of tests that expose race conditions or something that we don't have a deterministic way of reproducing. The first class is tests where we can run the test for long enough number of iterations that like it uses like we just throw more compute at the problem and we can get a reasonably reliable test. The second type of test is like it fails 1 out of 1,000 times when running on 200,000 cores, and we can't really write a unit test or a regression test for it. But most of our tests, our regression tests for race conditions, we can write pretty reliable tests that will reproduce the problem. It's just a matter of making sure that we run it for some number of iterations. Although we have consistently found, as new hardware has come out, we've had new tests break because new hardware is faster and new hardware is different in some way.
Thread sanitizer is the one true solution to these problems.
That's what we should probably be using. Yeah.
Like, because it will tell you like the file name and line number of the like on this thread there was a write here. On this thread or this 10 threads there were reads, right? And I saw no proof that there was actually a synchronization point between them, right? And like the difference between thread sanitizer and a world without it is much larger than the difference between a debugger and a world without it, right? Like it's just night and day. Like I cannot stress enough how much the sanitizers have been transformative for us.
Yeah, we haven't started to look at that yet, but that's on our to-do list.
So good.
And so I also had a question. So I work on this large code base. When I got started on this code base 7 years ago, I think we either had no unit tests or we had like one test.
We've been there. Yeah.
And so I was like, all right, we should probably have tests. And for I don't really know what particular reason, but I think ultimately simplicity, we didn't decide to go with some big test framework. We use Boost Lightweight Test, which is an incredibly minimal test framework, which basically just it's like a macro for like is this thing true or not, and like a couple other versions of that macro, and then
All that a test framework really needs to do for you is to have a concise way of saying, this is the invariant that I want, and to tell you when that failed and give you enough information that you don't need to run the test again.
Okay.
Right? The output from the invariant failure should be enough for you to say, oh, this was a 7, it should have been an 8. Right? And then you go track down why that was.
And so you think it's fine for like we have mock objects in places and stuff like that, but we don't have, our framework doesn't support it. We just sort of write them as needed.
Mhm.
And our project's grown over size, and it's now like this large project with thousands of tests that uses this very simple test framework. Is there anything wrong with that?
No,
Inherently?
not at all. I mean, the biggest change to how we write unit tests in the last few years has been, honestly, I started sitting down to look at, like, why are we using fixtures? Like, there was just a reflex for absolutely everything has a fixture, and you derive from it, and you have a set in the but that, and like, if you just refactored that down, it just become like test. And, like, all that GUnit is providing you at that point is run this, and the expect and assert macros. Like, that's it, right? And that's totally sufficient for the vast, vast majority of things. It was about to go to sleep. I lost track of, we're going back.
Do you use any kind of metric to define or to identify if API has been tested enough or not? Like a coverage, if the coverage is sufficient?
There's a lot of usage of coverage, and some groups swear by it. Coverage I find to be a little misleading because it can give you a false sense of security. Like, you went through that line, but you didn't necessarily go through that line in an interesting way.
What you can recommend about it?
Was that?
What you can recommend about it, because there's large code bases.
It's
large
better
code
than
bases.
nothing. Like, it is a weak signal that is easy to overly fixate on, but it is better than no signal.
But do you have better metric?
I don't. No.
Do you use mutation testing or anything like that?
There's been some discussion, but it's not widespread. And partly, like, my view is asserting that the tests are sufficient and correct and sane is part of the code review process. And we just treat code review very sacredly, right? You take it very seriously. And code review is not a thing that you can just have a metric for. Code review is just, this is engineering practice. And that's not an entirely satisfying answer because there's not a tool. And I know that we just want there to be a tool. But in the end, I think it's just, you're just going to have to get better at stuff. But there's someone that has a very important.
I have a question since you mentioned code reviews. So do you do code reviews before you have test results?
The unit tests for most things run in under a couple minutes. So.
Well, it depends if that thing is a file system. It's not going to run in a couple of minutes.
Yeah, it does.
You're testing the file system in a couple of minutes.
Chandler?
Having worked on one of Google's file systems and written tests for it, yes.
So how much of the functionality of that file system are you testing?
We had extraordinarily high coverage at the time I left France.
Part of the
And we-
infrastructure run
Like
lots and lots of tests
maybe
in parallel.
100%?
Let's say most of it,
So-
but like understand that I ran.
So, I managed file system development at Veritas, and I manage file system development at SGI, and I have VXFS and CXFS and XFS to my credit.
Yep.
It takes a long time to do a 100% test of an in-kernel file system.
So if I can maybe clarify something.
Yes.
We first off, we were doing unit testing.
Right.
And so we didn't bring up an entire file system. We had like fairly carefully factored modules, and we have infrastructure that
How do
runs
you unit test an in-kernel file system?
by taking the same code and building it in a unit test as well as in the file system.
Yeah.
But the other thing is we also have infrastructure that runs hundreds of thousands of tests in parallel.
Oh, okay. In
Which
that
also
sense,
makes
I
it much
understand.
faster.
I understood.
Yeah.
Okay. So the reason for my question was this. In companies where I worked, we used the policy that before you can present your code to review by humans, you have to have all the unit test results.
Mm-hmm.
And the sequence that we used to go through was, there's a formal specification. Based on that formal specification, one team develops the code and one team develops the test, including unit tests. We never allowed people to write tests for their own code. They might write tests for other people's code, but not for their own code. Before the code was reviewed, the tests were reviewed. And
I think that is a more formally defensible system, but it is not what we do. I do not know that it is necessary in my experience.
Do you have outside customers? Do you sell a software product to 3,000 or 500 or 1 million customers?
I mean, they're Google.
We're Google. I mean,
So, yeah.
I know you're Google. This is why I'm asking the question.
and in many ways, our scale is like I have 11,000 developers.
Yes.
So like when I have libraries that are being used, and when Greg has libraries, like the scale just internally is often very similar to what you're discussing. But
Right.
anyway, we were interrupting that.
Okay.
Are you enforcing code complexity?
No,
No?
we don't enforce much, not in a formal and metrics sort of way. It is everyone's responsibility to uphold like the guidelines of readability. Don't be overly complicated. There are sort of like rough guidelines on, your function is 90 lines long. That's kind of too much. You should probably refactor things. And people specifically have basically a badge for, you have demonstrated to us that in this language, in this code base, we should trust you. And every commit has to be signed off by someone that has that badge.
So the idea is that just going to be code review. That would
Yeah.
be basic.
And in practice, those sorts of human systems are easier to implement and tend to actually work. When you just have a tool, everyone just trusts the tool, and the tool may not be perfect. But I'm a big fan of human systems. So.
So you were talking about the invariants using the unit test,
Mhm.
but sometimes those are expressed as debug asserts also inside the code itself. So what do you compare the two approaches, writing unit tests and having invariants in them, or having these debug asserts which are having the invariants and as part of the debug builds? And
For a sufficiently complicated test framework, you can usually have invariants on that assert fired. That helps. I tend to not like the resulting designs, but you can certainly do that. So, Arthur?
That sounds kind of like something that I forget what name, but maybe log-driven development is the name that I've seen it used as in a blog where someone says, well, we can't possibly test everything. We just put logging stuff in there and we ship the product. And then if a customer hits something that causes it to log a bunch, then we'll go fix that. And I think that's decent actually. But I think you have to use it with unit tests or with some sort of test, because otherwise you end up shipping things that are
they
just
don't ship, they don't ship it as
Right.
part of it. It's part of the builds and the debug builds where
Yep.
you hit an assert and then that's
But someone has to be running the debug build, right? And either it's your customer running the debug build, or it's someone internally whose job is just to sit there and run the debug.
Well, no, you can just have a unit test that runs it in debug and asserts and has an invariant check for that assertion fired. Right?
But then you have to make up inputs, right? You need the input generator. If you just ship it to your customer is the input generator.
No.
You don't do that.
It is your job to provide unit tests to
That's
yes.
just your opinion, man.
It's true, but I'm the one with the microphone. You invited me here.
There is one more thing though. If you do the log-driven, then you're actually forcing your customers to do the integration test for you, because you don't
I
know
think he's
exactly-
joking. I think he's joking. I'm not 100% sure,
You know
but
what developers' salary You're insane. Like you idiots if I do that.
Yes.
Have you ever had a need to use random testing, randomly generated testing?
Doesn't come up often, but
No, it's, well, that's what I try to draw the distinction.
yeah,
So
like
it's not really fuzzing, but
Yeah.
for compilers, I think that's unavoidable.
yeah, I think that's probably true. Yeah, in front.
You said that you started of some places where we had 0 unit testing
Mhm.
to everything. Like, how do you get there, especially on a large code base? Like, how do you enforce it? Do you do it?
So Google got there before I started, and I'm very glad for that fight having gone the way that it did. Otherwise, my job would not happen. And by and large, it was there was a group that they were responsible for putting out. This was 2006. They were responsible for putting out the new web search build, like the weekly push, and that got harder and harder. And they got to the point that they said, no, we are not going to take responsibility for failing to push this because it just doesn't work in production, right? We are just going to say, no, you cannot land your change if you don't have tests, period. And there was a fight, and it got up to some very senior engineers, and the people took a look at it and said, I know that this is not how things have been done, and I know that this is not how things traditionally are done, but software engineering is a young discipline, and it is entirely possible that the needs right now are different than what they often are, and we are going to uphold this law of you cannot submit your change without tests associated with it. And that turned the inflection point. And by the time I got there in 2010, it was more or less taken as a given, anything you do is going to have tests. So I don't think we're good at good tests yet, but we are good at there will be tests. So, no.
About halfway through, you made the assertion that tests are not tested.
Yes.
And therefore, you need to be very careful with them.
Tests are sort of testing themselves, but
One thing that I've found true in a lot of code that I've worked on is that sometimes you may have a very high performance implementation of some data structure that you can build the same functionality with a lower performance version out of, say, STL containers. And so you can test a low performance implementation that is known to be correct versus your new system. And that can be really useful because then you can have pretty good confidence that you're actually testing the correct behavior.
Right.
This also comes up a lot in cases where, for example, you might have a version of an algorithm that runs on CPU and a version that runs on GPU. And you want to make sure that they are in conformance.
Yeah, I can see that. In the back.
So I'd like to make one comment on something that both you and Arthur said, those different ways. So looking back at the industry, it looks like the companies that were the most successful commercially, like Microsoft and Oracle and Amazon and some of the local companies here in the Valley, are the companies that found ways to have a lot of their testing be done by users and by customers.
I don't know that I would agree with that, but
Do you agree with that about Oracle?
I don't believe that there's a correlation between these things.
I see.
I think there's a correlation between shipping a lot of software and shipping a lot of bugs. And there's a correlation between shipping a lot of software and being unsuccessful. But that doesn't mean that there's a causal relationship, right? If you ship a lot of software, you get a lot of money. But if you ship a lot of software,
Right.
you ship a lot of bugs.
So,
It doesn't
and
mean if you ship a lot of bugs, you'll get a lot of money.
Right. And
But you probably will.
Right,
If you are
and
shipping lots of bugs, you probably are making lots of money. Someone's letting you ship things.
someone is letting you ship things. My point is not about success. My point is about in contexts where this is going to be code that you need for a while, right? This is how you ensure maintainability. Is your hand up, Chandler? Oh, geez. Chandler.
I wanted to call out something that didn't really talk about much, but came up in a site, like in one of your comments, about who is writing the tests.
Mhm.
I have seen quite a few organizations where there's kind of an interesting desire to do this, to kind of make sure that you're not kind of overfitting your tests to a particular implementation. But I think there's actually a problem with it that is more concerning to me than that benefit. And that is that if a different person authors the tests than authors the software, you don't have the opportunity to change the design and implementation of the software to be testable. And I think that without that, you often end up having very good tests in terms of their ability to find bugs, but having very high maintenance tests, relatively speaking.
Yeah.
And so from my perspective, I am often encouraging very firmly, no, we need to be authoring the tests as we author the system to figure out the right way to design the system to be tested.
API first design is
I'm sorry, but I have to answer to that, because I think that your comment implies a misunderstanding of what I meant to say, and maybe I didn't say it clearly. I said we didn't allow one person to write tests for their own code. I didn't say that these were distinct groups of people.
I know, but
Okay.
so the point remains. I think it's important for me as an author of code to also author the tests for that code, so that I internalize the lessons of how to write my code in a way that makes writing the tests effective and
But
facilitative.
The tests are the
internalize the ways by writing tests for somebody else's code. How is that different?
I think that they end up in practice being very different.
The tests are the first user of your API, right? And if you have designed your API in the abstract, on its own, you don't actually have the hands-on of this is what it feels like to use it, right? Designing the API first leads to worse results.
This breaks the most fundamental principles of engineering, and it gets back to the old discussion: is software engineering really engineering, and is software engineering different than all the other types of engineering?
So far it's different. The context, I think, is very, very different in the different types of software. For example, if I'm doing avionics,
Yes.
there are external DoD standards I have to meet, extremely rigorous. I have to get them exactly right, and the APIs I'm putting out probably don't change that much. But web search, I need to refresh everything every day, keep on going, and the reason, for example, you can set up a little bit of an adversarial or partnership between somebody who writes the spec, somebody who writes the implementation, somebody who writes the test separately, and engage together and write very solid implementation, maintainability, all that, great, thumbs up. But if you're in a hurry, and if your code is not avionics or medical or whatever, and you have to push out every day, things like that, the speed is crucial, and that speed you gain from the guy who's writing the code has to know this API, yeah, I should be able to write it.
I think it's even more than just speed, because when we look at, there's a lot of code that has evolved in our code base over time, right? It is stuff that, kitchen sink, common usage, fine. When we sit down to fix those things, right? When we sit down to redesign those from first principles, there was a period of time where we tried to do this by, okay, this is a thing, this is how we're going to design that thing, right? What turned out to be far better was, this is a thing, we have an indexer. Let's go see a random sampling of 20 places where that thing is used. Now, let's design an API that would make those usages look less crappy, right? And when you are inspired by usage, your API is more usable. This should not be shocking.
Can I refactor the code?
Right.
Safely, reliably, and
right.
at a low cost.
But if I summarize what the two of you have just said, you're saying in one sentence that there are shades of correctness. And
I'm not talking about correctness. I'm talking about usability.
But before you have usability, you have to have correctness.
Right, but that's fine. Correctness
is correctness.
No. Correctness is important. I'm not shipping anything that's incorrect. Just that's fine. But you can ship a correct, crappy interface,
Understood.
and you can ship a correct, pleasant to use interface.
And
And
then
you
you
are
can
less
correct-
likely to, and you are less likely to encounter or to stumble upon the pleasant to use interface if you are designing in a vacuum.
Okay.
I would assert that an interface with poor usability leads to incorrect code. How many security vulnerabilities
Yes.
are a result of the fact that the OpenSSL API is terrible?
It's
Yes.
not correct either, but that's a different story.
OpenSSL is not incorrect. Their code is designed correctly, but it is almost impossible to use OpenSSL
Right.
without shooting yourself in the foot at
Right.
some point.
Whereas, like, Greg tends to design us APIs that literally cannot be misused. Thank you, Greg. In the back.
When tests of concurrent APIs were discussed, from this discussion, I understand that unit tests that fail only sometimes for buggy code are okay. So the question is, yes, they do not always have the bug, right?
Sure.
So this is like a different kind of test. One would be like, functional test or something, or the other, like a different sort of test.
Yes.
Don't always
Yes,
right?
there are multiple flavors of good tests.
Yeah, so my question is, do you think there is enough justification to actually sort the unit tests you have into like types and then have different processes for them, or no?
I don't think it's a bad plan.
But like,
It's going to depend very much on your.
You are not doing that at the moment, right?
We're not doing that systematically. I strongly suspect that there are some teams that do that if their particular domain demands it. But like I said, we have like 11,000 C++ developers. I can't speak for everyone. So,
Yeah,
Bryce?
we do this to a degree. We have sort of different categories of our tests, and we have different categories of our concurrent tests. Like we have a whole separate pool of tests that test block-free code in our library, where they're handled differently in our unit test suite because they're the type of tests that could potentially fail one time out of like every 4 years. And we
TSAN.
Admittedly, TSAN could catch a lot of these things.
All of them.
But just what we have today, we do sort of split things into categories depending on the type of concurrent test that they are.
I have an answer and a question.
I'm going to go with Samir first, but
So, TSAN is awesome, but it's what's defined is defined databases, right? That's a particular class of concurrent.
Yes.
Cloud. So I'm going to pick on something you brought up on one of your slides, which is like, if you need testing hooks in your API or API is wrong.
not always, but
I
usually.
have found places in concurrent software, for example, I wrote the large part of the RPC package for code. And in there were sequences of events in, say, the stages that an RPC might go through, where there were particular sequence events where I actually needed a hook, a test where I could say, okay, stop right there. I'm going to set something else to happen, in the client. Now go. And, I needed to check I needed to force certain sequence of events to happen in the client. And yet, boy, was that not part of the API. And
That feels a little bit like a place where dependency injection and fakes and stubs might do the thing that you want.
Much narrower, like, I'm going to enable. We had this thing called test point, right?
Right.
Which we just occasionally use, which is just simply a blocking point that's it's free, like it disappears in production code, right? I think there's a macro in C++. But when you need it in test to say,
Yep.
stop there so I can set out the state, because otherwise waiting for this to happen naturally in a concurrent environment is very hard.
Yes.
Right.
And
I think there are cases like that. They are
Yeah.
infrequent.
Right.
And that's not what TSAN's for.
No.
Right. This is really just saying the API is not amenable to establishing this, but it's sort of gray box testing, I guess. It's I know enough about how the implementation flows. That
Right.
I need to stop it.
And the important point, I think, is I would argue that most of what I presented there, this is where you should start when you're trying to identify these are good.
Yeah.
Once you know what's good, you can bend the rules. Right now, many people don't write tests. Many people write tests, but don't know the difference between good and bad, right? Once we get to the point where people know what's good, then I will be a little bit more comfortable saying, like, yes, you can do this. So, yeah.
So what about performance testing for nowadays? Like people can, like for example, in Xcode, you can do performance testing of your function or method as well. But how do we? I mean, is it something also in practice, and how do we go from there into a bigger picture of how our software is performing?
Micro benchmarks are notoriously complicated. I have had so many experiences where people are like, this micro benchmark doesn't make any sense to me. And as it turns out, when you run that micro benchmark and turned the optimizer on, the optimizer said, you didn't use any of that. Poof. Right? And it just all vanished in a puff of optimization. Right? Like, as if applies. Thanks, compiler. And so crafting sensible micro benchmarks is, in my experience, still much more of an art than a science. And monitoring whether there are changes in those is super complicated on top of that, because having stable hardware and stable absolutely everything else, like everything can affect your micro benchmark performance. In the end, the things that tend to matter to us wind up being whole system benchmarks, macro benchmarks, where we say, what we actually care about is how many search queries per second can you answer. And those are noisier and harder to extract a strong signal from, but like if you're up in the couple % sort of range, then stuff will tell you stuff. So, Chandler.
I gave a talk about how to write micro benchmarks.
It's true. It's a good talk. Arthur.
So I have an answer and a question. The answer that I want to publicize out there is something that you didn't mention. You talked about like,
That happens sometimes.
Speaking of false positives, flaky tests.
Yes.
At Mixed Panel, one of the things that we do is if a test is green, then awesome. Like someone makes a pull request, we run the test suite, they get a green or a red. If it's a green, okay, don't care. If any one of the tests is red, we run that test a second time, or in general, n times.
Sure.
And if it goes like red-green, then, well, if it goes red-red, that's a failed test, and we mark your pull request as you failed the tests. If it goes red-green, we mark the test as flaky and notify the owner of the test that, hey, your test is buggy.
Yes.
So there is a sense in which a test can be buggy, and the pull request, we just go ahead and say, yeah, it's good as far as we know, this one test is buggy.
You don't have to tell me. Imagine living in a code base where, like, we are making changes to the very most central APIs and libraries all the time. So if we run a test, like, please run all affected tests. It is not uncommon to get, what's the number these days? Like 60,000 failures from those sorts of problems. This makes life a little difficult for us. We have, by policy, gotten to the point now that we can just ignore all of those. So there's slightly less safety, but
The Beyonce rule is even more intense.
yes, the Beyonce, if you
Put in
one flaky test on it, yeah.
Yes.
So, yes,
checking
but
for flaky test doesn't actually solve all the problems, because it's quite often that it'll be flaky because something is going wrong this minute, and when you rerun it in the same minute, it will fail again, but it wouldn't fail if you ran it 10 minutes later.
It
So
also
doesn't solve everything.
it also can be flaky because of the tester.
Yeah, you know where this goes viciously wrong? When the people providing the library, say for setting up big table in tests. Do something that make all the big table tests flaky. That's fun.
Yeah.
I was thinking more like,
They might
my
implement
test
the
is
effect.
because
The
hardware
test might be
somewhere in my
right.
test environment is broken.
Yeah.
Well, if the thing is intermittently failing, and that makes the test go red, green, that's not a good test in our view. Our view is that test, a test that goes red, green is like strictly worse than no test, because it's giving this mixed message of like, I don't know, something might be wrong, maybe not, I don't know. Like,
It
you can't
actually depends on context.
It does depend on context a bit, but in our particular context,
It's
we
a
have
red flag.
decreed that it's not a red flag. It's a weird red, green button or red flag.
I'd say that's red.
In our context, we just say that is too confusing. If you're doing that, please stop. We're going to make a bug against you.
As someone from New Mexico, just call it a Christmas test.
So my question, though, going back to Ansel's comment about who tests the testers and how you can make I'm a high performance data structure, so I make a whole harness that tests against the low performance data structure, but there's still no one testing that harness. There could be a bug in that harness that it only generates a certain kind of test and not other kinds, and we actually have a whole blind spot. And in fact, something that has happened a couple of times, or if it hasn't happened, at least I've imagined it happening, but I think it's pretty sure it's happened in our test suite, was that there will be a test that 6 months ago, it was testing something super important that didn't fail because no one broke it. So it's been green, and I go look at it today, and someone refactored this 6 months ago, and this test is not doing anything. 6 months, this has been green.
That's when you need mutation testing, and that's PhD land still.
To try making a small change to each unit test and making sure that it goes red when you do that.
No, to try making a change to every line of actual code and make sure that some test somewhere fails when you do that.
And that you have no tests that are green through all of those.
Right, right. Because if there is a test that you can't make fail by mutating the code, it's not testing anything.
Yes.
That's
true.
But wouldn't that like fail the
Do you think
compilation?
contracts in the language are going to...
This is why it's PhD land.
This is why it's PhD land. You have to generate
Generating corner
you have to
case,
generate
generate
things that compile but are semantically different in some atomic way.
But who generates the generator?
Kostya, and he gets it right.
So the question
Are
was,
you discussing the holding problem?
To a certain extent, yes.
yeah, the question over here was whether contracts in the language are going to change the testing structure. I honestly have no idea. I suspect so, but I think it's, if nothing else, it will increase discussion around contracts and invariants and things, and that has kind of natural follow-on to testing. So
At least for me, like the debug build of my library and the release build of my library can have very different behavior because of the amount of debug facilities we would have. And so we run our tests, we run separate tests for debug and release. So it'll change it, but I will still always need the tests that test the version without the assertions in it to make sure that that's right.
yes, we have had similar experience. So lastest question, I really need a beer.
Regarding mocking tests.
Yes.
They tend to be big and difficult to read.
Yes.
Because you need to sit up, and it's nightmare sometimes to code review that because it's difficult. A lot of thought, it's boilerplate.
Yep.
They have guidance for that in Google, like how to write a good mocking test, and when to write them, to not write, and what do you do about it? Because people doesn't write them because it's difficult to read.
That actually gets to one of the most important things for me in code review, which is I have just copped to the fact that I am not smart enough to understand your code. And so the majority of what I do in code review is ask questions without the, preposition that I'm really smart and I get what you're doing, right? So I'm just getting like, is this mock necessary? What are you mocking, right? And you start there. And 2/3 of the time, they just copied it from someone else in the same file. And there hasn't been a reason for any of this for 10 years. right? And then that just melts away, right? And usually what's under the hood there is you need like 5 lines of actually testing something. When it gets more complicated than that, you have to pay attention and you have to tread carefully and you have to have best practices. You have to try to, like in G-test, in GMOC terminology, prefer on-call over expect call, because what you want is the black box test. Like the terminology that I use jokingly is prefer on-call, because what you want is if you replaced the function you are testing with a magical unicorn and you fed in the input and magic happened and the correct output came out, do you care? Right? That is, do you care if your code disappeared and magic replaced it with something that does the right thing? Right? Most of the time you don't care. Right? Okay, great. I have magic now. That's fine. Occasionally you care. Occasionally you want to say, I am only allowed to make 2 file system calls. So I need to count those calls. Right? Then you are in a different world. Right? And I find, practically speaking, luckily, the on-call systems are a little easier to read than the expect call systems. And this is good because you want to prefer the black box testing over the white box testing anyway. But that is unfortunately the only depth that I have there. There is no perfect answer because it is a complicated setup.
All right, I think any further questions for Titus, you have to get in front of us. Awesome.